Well, hello, this is Philip Plump with the 1015 podcast. And today we're going to talk a little bit about, of all things, financial fraud. And where do we want to start with financial fraud? That's such a weird subject. You know, before the last presidential elections in 2016, for a significant portion of the campaign, a gentleman by the name of Paul Manafort was the campaign director for Donald Trump. And this has nothing to do with Donald Trump. This has to do with Paul Manafort. In any case, Paul Manafort, after the election, was indicted on 18 counts and convicted on 7, with the other counts objected to by a single juror. All the other counts were in concurrence with the jurors. So there was 7 counts that he was convicted on. 4 of those were for financial fraud. And what is financial fraud? If you are the owner of a company and you report a corporation and you report books at the end of the year to the government upon which you're basing your taxes, if you take money that came in as a loan, and instead of reporting it as a loan, you put it down in your books as income from sales. Now, income from sales looks like a really good thing to a bank, so you take this information that you've put into your books and you go to a bank and you say, I would like to borrow money because I've had this much sales. And the bank looks at your records and says, okay, we will lend you money based on this. And then you go and do something and you get insurance, and you use your financial records to get insurance, and then you report your taxes based on these financial records. Well, first of all, reporting incorrect financials as a corporation, not only do the officers of the corporation have to sign off on them being correct, but if they're not correct, that's fraud. If you take something that's a loan and say, no, this was sales, that's fraud, and that's illegal. And it carries a multi-year penalty for going to jail. But that wasn't exactly what Paul Manafort did. Paul Manafort saw that his company wasn't making it, and he decided that, yes, they had to show more income. So he went to his accountant and said, no, take this figure that you've put in as a loan, delete that figure, and put in a new figure that says that it's sales. So at that moment in time, he's got this accountant, the CPA, and the CPA does what he says to do. And this CPA happens to be somebody that runs computerized books, so they're a computer person, sort of. Well, you know, they're a professional, certainly, and they're not a software developer, but they're a professional, and they do what he says. So not only did he change how stuff was reported, which was illegal, but he got somebody else to do it for him. Now, in the trial, this accountant was one of the witnesses and testified that, yes, Manafort had insisted that this be done, and this person lost their CPA license and was forbidden by the court to work in the accounting field basically ever again. They didn't go to jail, but they get to pick a new profession, which, you know, that's pretty drastic in and of itself. And what Paul Manafort did was considered fraud, and consequently, he did go to jail for 7 years for federal penitentiary. Most people don't know this, but federal penitentiary also doesn't have parole. So if it's 7 years, it's 7 years. That's it. Okay? But, yeah. Now, the reason that I bring this up is this is an example of what is considered by most people to be the most common kind of financial misreporting, where the books are already done, and then they go back into the past and they change something so it looks better later. Now, in our modern world, we actually have a system that can prevent this kind of a change. We're beginning to see the use of blockchain for doing financial accounting, and the one thing you can't do on a blockchain is go back and change the past. And that's probably going to be a good thing. That isn't going to get rid of all kinds of financial fraud. Because, if the money had come in from a loan, but instead of booking it as a loan, it had initially been booked as income to the business, it would have still been financial fraud, and the blockchain would have done nothing to prevent this. So yeah, there are ways around it, but 4 out of 5 cases of financial fraud fall into this category. And you go, is this, and if it's that common a financial fraud, this is going to happen. And you as a computer person, you might be out there in the position of needing to know this and being able to say, no, I don't think what you're doing is even legal. So you need to have some background in what constitutes financial fraud. And to give you an example of this, I was working on porting the books for URS Griner, which was an environmental engineering company, to Woodward Clyde. They had merged, and we were combining the books. And the chief financial officer for the company came in one evening, and he says to me, Phil, would you put down $5 million for the amount of inventory in this place up in Canada? And I looked at him and I said, I think you could enter that. And he said, no, just update the database with this number. And I'm thinking to myself, let's see, when you count inventory, you count the number of widgets, and widgets come in all sorts of different prices, but you never see an exact 5 million come out for inventory. That seems really unlikely. And why would he want me to do it instead of him? Because guess what? He's trying to commit fraud and do a cover-up so that something looks better in this merger, but he's trying to pass the buck onto me. So if they ever come back on it, he can say, oh, I don't know anything about that. That was just the numbers that the computer reported. And that's the way it is. So you got to think ahead, okay, I'm going to be the computer person in this operation. Is what they're doing even legal? Is it right? What's the ramifications of this? Are they asking me to commit some sort of a crime by doing this? Because let's face it, the computer, what it tells you is generally speaking what people are going to go with. And unless they question it, it came out of the computer, therefore it has to be right. And that's not necessarily the case. If you put the wrong data in, or you go and change the data somehow, the computer isn't right. And a big part of what we're going to be talking about with machine learning is the fact that when you train a system with machine learning, that system is trained on whatever data you gave it. And if the data is wrong or incomplete, that's more likely than wrong. But if it's incomplete, then those things that it is not good for, you could get any kind of spurious result out of the computer. And machine learning is the process of, instead of us having the headache of trying to write a program for something that we don't understand, we give the computer a whole slew of examples. And with lots and lots of examples of what we're after, in one fashion or another, we say, okay, computer, from these examples, figure out what the program should be. And it's kind of cool that you can get the computer to do this at all. And when you look at something like one of the most important machine learning things that's happened in history is the Go challenge that Google did, and they actually won at the game of Go. And the program that they developed, the machine learning program that they developed for this, went through literally billions of Go games, following the rules and playing not just games that exist, but playing against itself with various representations of the game, where it could say, okay, if I do this, then I get this result. If I do this, I get this result. And it beat the world Go champion. So computer programs are now better than humans at this very difficult problem to solve. But even though that is really important, I'll explain to you why it's so important here in a second, but even though that happened, that doesn't mean that this has any implications for anything else. The computer program only knows that set of data that it trained on. And if the data was wrong or biased in some fashion, then the results are going to be biased. And it has no morals, it has no view of the world that says, oh, well, this is an exception. Now, the reason why that Go game is so important is because that's the thing that really kicked the Eastern world, China, Vietnam, Taiwan, Japan, into saying, oh, artificial intelligence could actually be really useful, which they had never really looked at before that way. And they went, if it can do that, what else can it do? But at the same time, this is the thing that has kicked them into finding out, oh, there are lots of things it can do and lots of things that it can't. And even if it can do this, this doesn't mean this is the way we want to do it. But on the other hand, okay, there are things that it's really good at. When I was working out in New York for IBM many years ago, one of the people that I worked with he'd gotten a degree in computers because he'd been working in a factory. Okay, it was actually the Vlasic pickle factory, and his job, along with a bunch of other people, was to size pickles. Basically, there was a conveyor belt with pickles coming down, and he would go, okay, this one's too big, flick it in this bin. This one's okay for restaurants. This one's okay for home consumers. This one is okay for, being in a baby pickle jar. And this one is too tiny altogether. It has to be chopped up into relish. And he would do this 8 hours a day. And his comment about this job was that, yeah, it was mind-numbing. They'd put you out there on the line, and if you collapsed after a few hours, they knew that you couldn't handle the job because there was just no brain power whatsoever. You just sat there and looked at pickles and flicked pickles. He was literally a Vlasic pickle picker. And this is what he did. For 4 years, he did this job. 5 days a week, 40 hours a week. 5 days a week, 40 hours, this was it. And later, I was involved in replacing the pickle pickers with a computer program. And basically, we trained a program on the different sizes of pickles and their shape and which ones were good and which ones were bad. And we basically replaced it with a little arm that could flick pickles into bins. It used some machine learning. And there you go. Okay. Now, what a horrible job. Seriously, can you imagine? And he said the worst part of it is after the first week, you just smelled like a pickle 24 hours a day. You were exposed to so much vinegar and so many pickles that you just had this odor about you. And everybody in the town where this was could smell the pickle pickers wherever they went. Let alone the fact that it was just, brain-frying, mind-numbing work. And it didn't pay very well. Minimum wage, horrible job. So this job has gone away because we can take a computer program that does vision processing, looking at the pickles coming through, and saying, this is a big one, this is a little one. Works great. That's a wonderful thing, at least as far as I'm concerned. It's good for Vlasic. These people can go do something that actually is better for human beings to do. On the other hand, you look at something like the Innocence Project. And in Texas, they have used a machine learning, actually the same underlying software, and they've trained it on doing sentencing guidelines. And the sentencing guidelines determine who gets parole, who gets sentences, things like this. And then you look at the results for who gets parole. And you say, why is it that black people are 1/5 as likely to be granted parole as white people? Because the training data in the past has this bias in it. It says, these are big pickles, these are little pickles. Little pickles stay in prison. And the computer has no compunction. So as you're going through this, you want to look at a bunch of different things and say, I've got to think about what the ramifications are. What are the biases in the data? How is that affecting things? And am I doing something with this data that is, in fact, illegal? Because having a bias like that in the data is, in fact, illegal. And those results are not suitable results. So when you look at this, it isn't just financial fraud. It's, what is the computer doing? Are the results really right? When I test this, am I getting the kind of results that indicate that what I'm doing is right? Or have I been asked to plug $5 million into the figures from nowhere, and there is no $5 million of inventory, and I'm actually committing a crime. Now, right now in this world, we're going to talk some about what is legal and what isn't legal in the software world next time. But right now, most of these things as a developer, you're not legally responsible for. But that's going to change sooner or later. And I think with self-driving cars, we're going to have the first real robots out there for people to use on a common basis. And the responsibility, the legal responsibility when there is an accident, and there will be accidents, and Tesla's self-driving is 3 to 4 times better than human beings now, but it still kills people. And there's still car accidents. Now, who's responsible? The software developers, the training data set, the person who, instead of paying attention while they're supposed to, according to the instructions behind the wheel, falls asleep and has the car speeding when it hits something on autopilot? And there's a lot of questions like that. But one of those questions, and I think you're going to find it more and more, is that the software developers are responsible for building a product that meets legal requirements. And consequently, you're going to have to know something about what are those legal requirements. What can you do that is, quite honestly, if not immoral, just out and out illegal with a computer? So financial fraud is the tip of the iceberg. And when we look at these different things, we're going to have to think about how does this fit into a bigger picture than just what we're doing at that moment in time. So that's the kind of testing we're going to have to think about, and where this stuff is all going. And I want you to pause and contemplate how broad that is going to be in 30 years, when half of all the jobs that you see out there today are automated. What is the responsibility? Not only is it a phenomenal opportunity, but it's also a big responsibility. With that, I will catch you later.